All right, welcome back to episode 3 of Physical Dimension. Episode 3. In our last class, we solved momentum and impulse last, and then we established that momentum and impulse they have the same quantity. Now, in physics, there are several quantities that have the same physical dimension or have the same units. Before we continue in our physical dimension, I'm going to show you just a few of them. Number one, so I'm going to look at quantities that have the same quantities with the same physical. Then we also have time and period. Time and period, they have the same physical dimension. Speed and velocity. Though speed is distance over time, velocity is displacement over more. They have the same physical dimension. Force and weight have the same physical dimension. So solve them and find out what I'm saying is true. Moving on further in our physical dimension, let's go solve for work. That is number 9. Number 9 is for work. What is the formula for work? Work is actually force times distance. Force times distance. Force is not a physical dimension here, but then distance is a physical dimension. So I'm going to open up force. Force, the formula for force is what? Mass times acceleration. Then distance is there times distance. Mass times acceleration, then times distance. Moving on further, take note, mass and acceleration is for force. Mass is a physical dimension, distance is a physical dimension, acceleration is not. So we rewrite mass times acceleration now will be broken down as what? Velocity divided by time. Then I have my times distance here. Mass is a physical dimension, time is a physical dimension, distance is a physical dimension, but velocity is not. So I'm going to break down velocity. So I'm having mass times velocity is what? Distance divided by time. Then I continue, divided by time times distance. So observe what is going on. This mass is what we have here. This distance is what we have here. Acceleration is velocity divided by time. This divided by time is here, but this velocity is distance over time. Looking at them now, they are all in the same dimension, physical dimension. So I can now change it. My mass becomes what? M. Distance becomes L. Divided by time as T. Divided by time as T. Then times my distance L. If I go on further, we have mass times L times division into times and become 1 over T times 1 over T then times L. So go on, you have M times L times L. You have L times L is L square, so it's ML square. Then 1 times 1 is 1, T times T is T square. That gives me times 1 over T square. So if I progress, I will have ML square T raised to power minus 2. So that is the dimension for work. Mass is 1, you have it there, L times L, L square. 1 times 1 is 1, T times T is T square. So 1 over T square is this. From a negative index law, it becomes T raised to power minus 2. So going on further to number 10, we deal with now pressure. Pressure, physical dimension of pressure. What's the formula? Is force divided by area. So what is the formula for force? Mass times acceleration. Mass times acceleration is the formula for force. Then divided by area. Area is has a formula also, which is length times breadth. See, in this case, there's nobody who is a physical dimension initially, so we had to open up force, and force gave us mass times acceleration. Then area gave us length times breadth. Moving on further, mass is already a physical dimension. Length and breadth, they are already physical dimensions, so I won't disturb myself again. I'll be working on with acceleration. So I write here now mass times, what's my formula for acceleration? Velocity divided by time. That's for acceleration. Then divided by length times breadth. Please take note, this length times breadth we have there is for area. So we are not going to do divided by only length, because it also be divided by area as a whole. So this will be taken as one full entity, which has to be dissolved before we can now apply the division. So velocity will be broken down further. We have mass time. Velocity is what? Distance divided by time. Then this other divided by time is coming there. Then divided by length times breadth. Good. So everybody is in physical dimension. So we're going to change them now. My mass now becomes my m. Distance becomes L. Divided by time becomes T. Divided by time becomes T. Divided by length here becomes L times your breadth here, which is L. So going on further, we're going to have mass times L, which is ml. Division becomes times 1 over T. Division becomes times 1 over T. Don't change this yet. Divided by L times L is what? L square. Then now this is for area. So we can now apply the division. ml, 1 times 1 is 1. T times T is T square. Then times, division change to times now, 1 over L square. So if you look at it carefully, this is L square, this is L. Remember your algebra, L is going to divide one of the L here. So L will remain down. So now I now have M, this L is gone, times 1 over T square times 1 over L. So what just happened here? This is what just happened. This L divided this square out. So you only have one of the L down. So you have M T raised to power minus 2, then L raised to power minus 1. After applying negative index law, negative index law. But we always write M L T. So M L raised to power minus 1, T raised to power minus 2. This is for pressure. If you have been following the class, please, if you're just meeting us for the first time, this is the third episode of physical dimension. Go back to the first episode so that you understand what we are saying very clearly. Now, moving on further, we want to solve for pressure and for period and for frequency. That will be in our next episode.